Welcome to the Skynotes for the BAA March meeting. It's very strange being here without an audience. As a school teacher, I always like to see people in the audience. I remember once giving a lecture at the University of London and thinking what a nice audience it was. But no one was sitting in the front row. And when they put the lights out for the lecture, the entire audience disappeared, all apart from the deserted front row, of course. This evening is somewhat unusual. Not only am I not in London, but you're not in London either. So this is going to be a summary of what you can see in the night sky with a little bit of historical perspective here and there. I'm going to start with the sun and effects on the Earth's atmosphere, such as the aurorae. And on the first slide here you can see the annual mean daily frequency of sunspots plotted against year. And I've actually chosen to show you my own personal observations since 1973, in which 4 solar cycles are carried. The one that peaks around 2013-2014 is cycle 24. The current cycle is cycle 25, which has now begun. I was looking on March the 8th, and there was a sunspot at latitude about 30 south, which is quite high latitude, and therefore a spot of the new cycle. So cycle 25 has definitely begun, but is expected to be quite low compared to the cycles before it. And if we go back a few years, we can see that the cycles in the 70s and the 90s were really quite strong. Here I've plotted the annual mean daily frequency. In the little inset there from the Royal Observatory of Belgium, I've plotted their data on sunspot number, which is a slightly different count, but nonetheless you can see that the peak in 1980 was very much the highest of dot. And of course, with this lessened solar activity, we're not seeing quite so much in the way of aurorae. I'll show you first of all some pictures and then some comments from the director of the solar section, Lynn Smith. Here's a picture from Alan Taff, and here's one from Dennis Zinski. And we can see that these are beautiful displays. Of course, it helps to live in the right place. The comments that I've received are that solar activity is very low, so we've got very few sunspots. We've got no coronal mass ejections. And from the aurora section, Sandra Brantingham tells me that there have been some aurora sightings, but they're caused by coronal holes from Scotland. And she does give a tip, though, for the armchair observer, those of us who aren't far enough north to look for aurora most of the time. She recommends the Shetland Tourist Board webcam, which faces north, and there it is. So I thought I'd have a go with this, and here's the result. Unfortunately, it's a nice shot of the harbour lights at night and what is either cloud or fog, but maybe you can try it and have better luck. And if you don't like that, well, cliff cam number 2 catches up on what the puffins are doing in the island, so that might perhaps be more interesting for some of you. But do have a look at the sun, because activity is expected to pick up. Turning to comets now, and I'm thankful to Nick James for this information and also for uploading these slides online. The comet C2017 T2 is currently around magnitude 8.5, and it's expected to come to perihelion on May the 4th, now observable in small instruments. And of the many pictures at the Comet website, I've selected just one, which I'll show you in a moment. You can see it's quite high above the horizon. It's passing through Cassiopeia here, and it's going to be well placed, even though not particularly spectacular. Here's a nice image of it showing a tail from Martin Moberly, and you can see the slightly yellowish colour, the coma there, compared to the white stars. There's another comet, C2019Y4, and this one might actually reach naked eye visibility next month, perihelion, May the 31st, and it's quite interesting that this might have had a common origin to the Great Comet of 1844. Here's the path through the sky, Dallas here, and here's a nice image, and I picked this false colour image by Nick Haig because it does show something of a tail, perhaps a forked tail there, and there you can see the star trails. Now, another thing that was quite interesting when I looked up what was going to be visible in the handbook this year was the April Lyrids meteor shower. So let's have a look at the data for those. So if we look in the handbook, we can see that the maximum is on April the 22nd, 0 hours. The limits are about 16-17 days, and 2020 is a very favourable year, and that's because the moon is out of the way. The maximum number of meteors that you're likely to see in an hour at any one time is about 15. That's obviously radiant overhead. And I was interested to see in the handbook that it says that there are rich displays in these years here. And I thought it would be fun to look back and see what was the evidence for those. So 1982, first of all, there's a picture here of the activity curve of the Lyrids done by the director of the day, George Spalding. And we can see that the rate for the Lyrids most of the time is around a dozen an hour at the best, but for this short 2-hour interval on April 21 to 22 there was this very sharp spike where we got peaks of up to over 100 meteors an hour for a very short time. What about 1922? For 1922 the meteor section director was Grace Cook, and here's a picture of her from English Mechanic magazine at her observatory near Stowmarket. And 1922 she happened to publish a section memoir which gives detailed reports on the Lyrids and all the other showers. And this is what she said, that the shower was observed in good weather, gives the date and time of the maximum, and she mentioned some fine meteors were observed. The work that they were doing in those days was often to obtain duplicate paths to get the true directions of meteors by triangulation, but they're also interested in the rate, and on this page here in the little yellow rectangle I've given some of the details of the watches by some famous observers. C is Cook, the director, P is J.P.M. Prentice, who would succeed her in the following year and be very distinguished in that role for 30 years, CN, Edward Collinson, who was well known for photographic observations. What's very interesting here is that Cook sees 41 meteors, 28 of them were Lyrids, Collinson sees 19, of which 9 were Lyrids, and Prentice sees 71, obviously a little bit darker where he was living in rural Suffolk in those days, but only 17 of them were logged as being Lyrids, which is an unusually small ratio. Obviously that wasn't a meteor storm. There's a summary here of all of the showers that the meteor section observed that year with an entry for the Lyrids, not a particularly rich display. Well, there were reports from overseas. This is a map showing some of the tracks of the Lyrids observed from the magazine Popular Astronomy, published in the USA for 1922. But where was that meteor shower? Where was it? A myth. Well, no, it wasn't. I decided to have a look into my library, and I found this book by Charles Olivier, who was the meteor section director in America of the American Meteor Society, and he writes in his book, April the 21st, a strong maximum was occurred from Eastern Europe, and there's a reference to popular astronomy. So I looked it up, and here it is. And it turns out that the shower was observed by Henry Norris Russell and his wife, who were then visiting Greece, and he reported 63 meteors within a period of about 50 minutes, and then a very sharp fall. So I looked into this a little bit further. There he is, a nice picture of Russell from Princeton University. Now, he observed this shower at 10 p.m. from Greece, so that's 20 hours UT, and the UK watches began 30 minutes later, so the British observers just missed this famous shower. By the way, of course, this is Russell of the Hartsprung-Russell diagram. It was, of course, Hartsprung paper, 1906, and Russell, who tried to make an astrophysical interpretation of it and actually became the more famous. Unfortunately, he considered that red giant stars were condensing onto the main sequence, and in fact the evidence is the other way round. Here's a paper, later paper from 1960, which draws attention to the disparity between the British results and the Greek results for that year. And if we go back one more year, 1803, I'll leave you to read this if you want. It's again from Olivier's book about a meteor shower seen from America in Richmond, in fact, in 1803, and that was really the most spectacular of them all. And this led people to conclude that the particulate matter in the stream of the Lyrids is very condensed in some places, and obviously in 2020 we want to make observations of that to ensure that we complete the historical record. So there might be other parts of the stream that are highly condensed and will produce many meteors, looking and observing. I'm going to come on now to Betelgeuse, and as we can see on this slide here of Orion, it's a very bright, strikingly red star which you can't miss in the night sky. But recently it's been in the news for being considerably fainter than usual. Let's have a look at a few facts about Betelgeuse. It's a pulsating supergiant star. It's very large compared to the Sun, 20 solar masses. The diameter varies. It's from the orbit of Mars to the orbit of Jupiter, and it's actually the first star whose diameter was ever measured by interferometry, 1920, using the Mount Wilson 100-inch telescope. It's also, in later years, the first star that was actually directly imaged. So it's a variable star. The brightest it's ever been is about 0.4 magnitude, and it's classed as a semi-regular variable. It's 425 light years away, and as we can see here, most of its energy isn't emitted in the visible region. I had a look on the BAA website to see which members might have been observing this. I found these results by Tracy Haywood, which cover a 10-year period, and we can see there's quite a bit of variation. However, for the period that she's observed, up to 2018, the star was quite bright. So one of the problems with Betelgeuse, of course, is that it's a red star. It's well known that red stars are very difficult to observe because they tend to become a little bit brighter as you look at them for some time. If we change to a black and white version of this slide, you can see that it looks much less impressive. So the AAVSO say it's difficult and challenging to observe, but you might be able to find a red star at the same altitude. There's really only one red star at the same altitude that you might use. That's of course. Let's have a look at the BAA's own variable star section chart. And here we've got Orion. We've also got Gemini up here, and we've got Taurus the Bull over here. Aldebaran is a useful comparison star, although the star and Betelgeuse are, of course, at different altitudes. But if you pick the time in the evening correctly, of course, as the constellations are setting, these two stars will be at a very similar altitude. What you don't want to do, though, is to make observations in twilight, because the blue sky will accentuate the contrast with Betelgeuse and make it even more difficult to estimate. So I had a look online at the AAVSO website, and you can see this rather blobby looking chart here, which shows quite a lot of variation within the year, quite a lot of scatter, personal error as well. And basically these blobs come at yearly intervals. There's a little gap, a seasonal gap, when it can't be observed because it's too close to the Sun. And we can see here, at the end of 2019, a considerable dip down towards magnitude 2, but probably not reaching magnitude 2. Here we can see the data spread out more. You can see a considerable amount of scatter and other forms of recording other than visual shown there. We go on. I'll dare to put some variable star estimates of my own here. When I started looking at it in January, 1.7 to 1.9. And then at the beginning of March, I thought it was getting brighter. I observed a few nights ago, it was definitely considerably brighter. So although these estimates probably aren't very good, I'm not a variable star observer, they show the general trend. There are various factors why Betelgeuse might be variable. There's a variable hot spot which was discovered by HST 1995, much hotter than the surroundings. That might in turn be affected by the oscillations which have been found by the International Aurora satellite. There might be a stellar disk containing dust, and also the diameter of the star is variable, so we've got various reasons why the temperature, size and brightness might vary. There are some pictures here showing the variable bright spot, what might be dust on the right hand side, and all I can say about this picture that I found online is that I wouldn't want to be in this spacecraft if the star was expanding. But there's nothing new under the Sun, or under Betelgeuse for that matter, and I found in an old BAA circular, 1945, Betelgeuse is at present unusually faint, and suggesting that observations be made. There were observations came in, and Rives at a later meeting of the BAA reports the observation here, and I'll leave that for people to read. So that was a fade in 1945, this was quite a deep fade this time, but it doesn't look as if Betelgeuse is going to explode any time soon. Another thing that association members are interested in, and Roger Dimmock in particular, exoplanets, and he'd like me to mention that there are several exoplanet transits coming up during the next 3 months. All the full details are given on the section website, and we've actually got a result here in the little inset, a transit light curve by Martin Crowe showing where the mid-time of the planet transit was very close to the time. So more details of that. I'll mention Venus briefly. Venus you can't miss in the evening sky at the moment. Here are some drawings of mine. These are with a 3-inch refractor at low power. You can see the bright cusps, a bright area on the limb, some weak atmospheric shadings. If you really want to get good results, you need to take images with an ultraviolet filter. A deep blue filter will also work quite well. One of the things we're interested in is timing the moment where the planet was exactly half phase, dichotomy, and that, according to my observations nights ago, when the terminator was absolutely straight. I'm sure other observers have made that. As we go in towards inferior conjunction later in the year, the planet will be quite high on a dark sky. This is a time thermal emission with an infrared filter if you've got a CCD camera, or the ashen light if you're looking visually, and there's plenty about that recently in reports in the journal. But this is a good moment to have a look at Venus and to try and catch these elusive phenomena. What about some other targets? Well, Venus I've mentioned. Greatest elongation east is on March the 24th, which is the day before the BAA meeting was supposed to take place. An interesting conjunction on May the 22nd. Venus will be just less than a degree north of Mercury. Well worth catching this, perhaps on a daytime sky. It's always surprising to see how tiny Mercury is compared to Venus and how dull it is. The other thing that you might like to do in the spring, as spring has now arrived, is to have a look at some of the well-known galaxies in Leo. Leo has many of them, and as Nick mentions, in the coming months there'll be marvellous opportunities for seeing these. Have a look at the February journal on these pages where Nick gives advice and tips. I can't conclude Skynotes without mentioning Mars, so I'm going to mention Mars now. And Mars has been badly placed at the moment. It's in the morning sky, but it's very low at the moment, a very tiny disk of about 6 arcsecond. It's going to come to opposition in October, and it's going to be a very good opposition for Northern Hemisphere observers. But even at the moment, observers in the south are making very good observations. I'd like to show you these images by Clyde Foster from South Africa. And on this first one of March the 8th, we can see a little bright yellow patch, probably 3 patches in fact there, of dust. And this dust is over the region of Zephyria. If you go to the Mars section website, you can download maps of the planet showing where Zephyria is. Longitude there about 160. And on the right, it's almost reaching to the region called Aeolis. So that's interesting. And I look back in the historical records, and we have 2 previous occasions where dust occurred at about the same longitude at the same season, but there have been very many years in between those occurrences. Those were as long ago as 1937 and 1969. We go to the next day, March the 9th, we can see those dust clouds are fainter and they appear to be dispersing to the east. On March the 10th there's just a trace of the activity left. By the way, these clouds on the left hand side of the image are the clouds over the Tharsis Montes. On March the 10th you can see 3 little bright spots there, and those are the 3 giant volcanoes, and just below them to the right another bright spot, which is the orographic cloud over. So what about past oppositions? We know that this year is going to be a perihelic opposition. That's an opposition which occurs within 90 degrees of perihelion. So it's going to be a good opposition. It's going to be a big disk size of over 20 arc seconds, and the planet is going to be reasonably high above the horizon. So it's interesting to look back at what oppositions are similar. The same characteristics recur at intervals of 15 or 17 years. So if we go back to 2003-2005, you have a look at the reports uploaded onto the Mars section website. That will show you the sort of seasonal phenomena that you'll be able to see in 2020, because these phenomena are mostly seasonal dependence. Of course, we can't predict anything about dust storms. We can have a pretty good idea of how big the polar cap will be at a particular season, what white clouds might be visible, and so on. So do have a look when it comes to opposition, but if you have an adequate telescope and a camera, you might like to get up in the early morning and start. And once, as I prepared these slides, of course something else happened. I haven't had time to put the slides in, but in the last couple of days there's also been evidence of some dust in the Hellas Basin, in the south of the basin. There's been some interesting images there from Australia, from Neil McNeil, and from other observers favourably placed to see that activity. I thought I'd show you the most closely comparable opposition, and that was actually 1941. Not the best time to be observing from the UK, and certainly not from London. So the opposition then occurred in 1941, and here are some lovely drawings made by the astronomer F.J. Hargreaves. And Jim Hargreaves was, of course, an optician by trade. He was a professional optician, but he also made himself a wonderful 14¼ inch mirror, which the BAA now has. And this mirror enabled him to make many beautiful planetary drawings, mostly of Jupiter, of course, but he also observed Mars. So some lovely pictures here showing the South Polar Cap at the top. Now, if you want to see a larger South Polar Cap, you'll have to get up early now and watch the planet in the months before opposition, because by the time it gets to October we're getting down to quite a small size in the Martian southern summer. The markings that you can see here are, of course, the same markings that we can see today, but their shapes have changed subtly over the years, sometimes drastically, by the deposition or by the removal of dust. We can see in the second slide for September the 18th, we can see the Solus Lacus region. The shape of that is quite different today, and there is a streak to the right of Solus Lacus called Phasis, which reappears from time to time, and that's visible at the present time. On the October 7 drawing, we can see the famous Nepenthes Canal running out of the preceding side of the Syrtis Major, and that hasn't been observable since the 1970s. And there are many other features. I could go on about my favourite planet, but I think I probably won't. So the BAA, despite the war, was able to make excellent observations in 1941. And there were many famous names, such as the Reverend Phillips, M.A. Allison, Henry Wilde observed from London, despite the Blitz, and made many useful observations. And this was published later, some years later, as a very detailed report. So my message at the end of the slides this evening is to keep calm and carry on observing. I hope that all of us will be okay in the weeks ahead. It's a time of national crisis, but I'd like to say one or two things, if I may, and that is that a lot of the things that we observe in the sky are invariable. So if we don't observe them now, the moment has been missed. If we weren't looking up at Betelgeuse, we wouldn't have seen the fade of the star and its eventual recovery. If we hadn't had the observations from Australia and South Africa, we wouldn't have these records of these Martian dust storms. So the historical record would be missing. So in these times of enforced leisure, perhaps there's something you'd like to do. Perhaps you're making a telescope. Well, if you were, this is the time to finish it. If you wanted to start variable star observing and to choose a variable and to make observations every night, this is the time to do it. If you want to start planetary observing, Venus is there, other planets will be coming up, and this is the time to do it. If you've ever wondered about the galaxies in Leo, this is probably the moment to have a look. And I know several observers have been looking and also writing up their observations. And finally, one other thing, if I may, it's great to see all of these observations coming onto members' homepages on the BAA website. But please, please send them to the section director as well, because we don't have time to look at all of those individual pages on the internet. We're busy receiving observations from people, making them ourselves, and carrying out analyses. So I think it's very important that you send in those observations, which might be a lot better than you think. So good luck, keep calm, and above all, carry on observing. Good night.